Uh, I think now you're the co-host, Dr. Jyoti.
Okay, I'll check.
Yeah, I'm able to see your audio, video is clear. Audio, video, everything.
Okay.
Yeah, PP share, we'll just check it out if you want. Yeah, it's visible.
Okay.
Yeah, your screen is visible. Yeah.
Okay.
Thank you. So I'll just, we are just asking the girls to have a quick lunch and join.
Okay.
So, yeah. So they should be joining anytime.
Okay. Okay.
Yeah, yeah. I'll just monitor them and get back. Yeah. Dr. Jyoti, we'll just wait for a few more minutes. Dr. Geeta also said she'll join.
Okay.
Yeah, so I'm just waiting. She said 11 o'clock. She had another meeting to, inaugurate or something. There are
Okay.
several programs simultaneously happening. She said 11 o'clock sharp, I'll be there. So we'll
Okay.
just wait for her. And in the meantime, students are also joining.
Okay, that's fine.
Yeah. I hope you saw the program invite. The program card also was, I shared it with the new invite. So, yeah.
1 minute. No, I'm
Yeah,
not.
in WhatsApp. Yeah. Maybe shall I share it again in another WhatsApp? But if I come do that, I'll have to exit this meeting then. Yeah.
Hello? Hello?
Hello.
I have joined, Ma. You can start whenever you want. Hello? ஹலோ வராதில்ல இந்த மெயில் ஐடி பண்ணாதானே வரும்.
அஜிதா
சொல்லுங்க மேம். சொல்லுங்க மேம். கேக்குதா மேம்?
Yeah, am I audible now? Yeah. Okay, since shall we
Hello?
start the meeting, ma'am?
Yes.
Yeah. Okay, ma'am. Over to Kavya to start the proceedings.
Is it audible now? Yes. A very warm good morning to one and all present here. It's a moment of pleasure to welcome you all, the guests who are present here today on this webinar. I'd like to extend a special welcome to our guest speaker, Dr. Jyoti Shivalkar, ma'am, our principal, Dr. R. Geeta, our head of department, Dr. D. Annapurni, and all our faculties. Now, I request our respected principal, Dr. R. Geeta, ma'am, to set the tone for this webinar by welcome address. Over to you, Geeta, ma'am.
So a warm good morning to all who are here. And we are very happy to welcome Dr. Jyoti Shivalkar for a wonderful topic on understanding statistics in an experiential way. I can see a lot of playful things in the screen itself. Cricket, then basketball, and of course there are roses. It's a very interesting topic. But one thing I want to talk about this speaker is that, so I have met Dr. Jyoti some 15 years before, right? I think we met in a conference, and also we met during some refresher course. Even at that time, I used to just admire her way in which she used to explain the concept of probability with using some coins in an experiential way, right? By means of some experiments. And she was also very particular that this should reach all the undergraduate students also. That is, statistics should be taught to the students, and students should learn statistics in the way which they have to understand. So I was really impressed upon by the way in which she used to talk about statistics at that point of time. And so the years have passed by, and Dr. Vijay Sri is a close friend of Dr. Jyoti, and it is happening now. So this is also a right occasion wherein students have to know that statistics cannot be used by all, right? Now it has become more or less all disciplines. They use statistics because they know how to put it in SPSS. So there are many inbuilt programs which are available. Once you feed into it, you get always the output, and they know how to interpret the output, and they finish it off, and they are all doing a wonderful job. But being statisticians, you are now in a very important role, and I'm really happy that we are getting statistics students, the strength of statistics, undergraduate statistics students, as well as PG biostatistics is increasing day by day, and all students, they learn statistics in the way we intend to learn them. And it's the growth and it's the dedication of the staff in the department also. So we are really happy that Dr. Jyoti is here to emphasize on how statistics has to be understood, and now it is an experiential way, in an experiential way. So we are waiting to hear from her as to what different now she is going to tell us with this COVID-19 pandemic, and most of them into this online mode. Most of the students, they have a lot of resource materials with them, and now I'm really interested to know how madam is going to impress upon students as well as the faculty as to how to understand statistics by means of experiments. This will in fact help all the faculty also to put forth a concept in statistics to the students, to put forth to the young minds, right, who want to take statistics as a career, because data analysis, so much of career growth is there. And if these students are able to follow and able to practice whatever madam is going to say today, I think that would be an added advantage for them to face any data analysis also. So I'm really happy to have Dr. Jyoti Shivalkar ma'am here. And once again, I thank you, ma'am, for being with us, and a wonderful topic, which I'm also eager to hear from you. Thank you so much.
Thank you, Geeta ma'am. That was such a warm welcome. We can see how much you admire statistics and Jyoti ma'am. So like, aren't you all eager to know about Jyoti ma'am now? My friend Harshni Natarajan is here with a perfect introduction. Over to you, Harshni.
Thank you, Kavya. Respected Principal Madam, teachers, friends, a very good morning to all. I'm Harshni Nataraj, and today I have the honor to formally introduce our guest speaker, Dr. Jyoti Shivalkar. She is a professor with 36 years of teaching experience and currently heads the Department of Statistics of Hislop College, Nagpur. She has around 18 research papers published in reputed national and international journals. And she has also 3 minor I'm so sorry for that. And she has also 3 minor research projects sponsored by the UGC to her credit. Apart from this, she has also provided statistical consultancy to many PhD researchers in various fields like medicine, management, engineering, and so on. She has also delivered 30 invited talks on research methodology at various institutions and has also given guest lectures on various topics in colleges affiliated to Nagpur University, in pre-PhD workshops and NSSO training programs at Nagpur. Dr. Jyoti has worked as a faculty for biostatistics course at PG Department of Microbiology for over 6 years. She has also worked for the Indira Gandhi National Open University as a faculty for PG Diploma in Applied Statistics. Dr. Jyoti and her colleague, Dr. Vrinda Joglekar, together developed innovative programs like StatStorm and Statistica, which essentially are intercollegiate statistical quiz and workshops specifically for the students of statistics. The aim of such workshops is to let people know about the real-time applications of statistics. And as someone who has been a part of this workshop, I can say this for a fact that Statistica event is not just informative, but also interactive with various activities for the audience to participate in. These 2 programs became so popular, understandably so, among the statistics community that they were invited to conduct these activities at various institutes like Vuya College in Mumbai, Ferguson College in Pune, Narsi Munji College in Mumbai, and many more. Last year was the Silver Jubilee of Statistica workshop, in which around 400 students participated all over India. Students from our college took part in it too. And a cherry on the top is that she, along with her colleague Dr. Joglekar, has also authored a book. It's called Do It Yourself. It's an activity book for the UG students of statistics, the book launch of which happened last year during the Statistica event. Without any further ado, please join me in welcoming Dr. Jyoti Shivalkar ma'am. Welcome, ma'am.
Thank you. Thank you, Harshini. Nice to see you again. Okay, good morning, all of you. I wish to convey my thanks to Dr. Geeta, Principal and Head Department of Statistics, SDNB Vaishnav College for Women, Dr. Annapurni, Head in charge of Department of Statistics, and my dear friend, Dr. Vijayashree, for inviting me and for giving me a chance or giving me opportunity, I can say, to deliver my talk. And thank you, Geeta madam, for recalling those moments of conference. I do remember you, and of course, I always remember my friend Vijayashree. We met, Vijayashree and I have met in the recently means, of course, we are just not considering these pandemic years. So I'm saying recently, but we met in the, I think, Loyola conference at Chennai. And we had many times we interact with each other and so on. So I'm happy, Vijayashree, that you invited me to deliver a talk on understanding statistics in an experiential way at your college. So as a statistics teacher, I feel that statistics is an applied subject. And the course outcome of the UG with statistics program should be that students are capable of doing basic statistical analysis. They should be able to use statistical techniques that they have learned on real life data sets. Dear students, data are available on all walks of life. Only we should be able to aware. We should be aware of it. Learning statistics should be a fun field experience. That is what I feel. So today, the objective of my dear students, the objective of my talk is to make you aware that how statistics can be learned experientially. And some teachers of statistics also can develop such type of experiential way for in their syllabus of statistics. So I'm here to outline the basic concepts of statistics through experience, through different experiments. So I will introduce you some classroom experiments. I will introduce you some field experiments. And my objective is basically to develop the understanding about the basic concepts of statistics. If the basics are clear, then I'm sure the journey is very, very clear and very beautiful. And many students will take up statistics further for using statistics fruitfully to draw conclusions after the conclusions should be informative and useful to the community. So here I'm telling you the outline of my talk. Outline of my talk is generally, first I'm explaining you some importance. How important is that? How can we make the class very cheerful? Then I will show you some interesting findings in the literature, statistics literature. Then of course I will explain you some interesting classroom experiments which are very, very easy, which the data are available in your campus, around your house, etc. And 1 or 2 field experiments, and then statistical treatment to sports data set. Then some internet data sets are available. How can you choose those internet data sets for your experiments, for designing your experiment? That I will explain. And finally, for students, I will explain structured data analysis. Means when we go to the market and purchase vegetable, and if you put the vegetable directly in the compartment of the fridge, what will happen? It will just get damaged. Like that, when you put the vegetable in different compartments and store it nicely. Like that, data when you collect are very, very complex. You need to scrutinize the data and you have to use different statistical techniques to come to fruitful outcomes. So what is the structured data analysis? This is especially for students, not for teacher, but the students should know, because they should be aware about the data that are available around them and how to do the structured data analysis for students projects. And then I have added understanding diagrams. You may be in the descriptive statistics first year course. You might have, all students might have understood the diagrams, and you might have used them through charts, etc. But given a particular situation, I am showing you all diagrams and I am asking you which diagram is the most suitable in the current situation. So I need here some interaction. And finally, I will submit the summary. Okay. So the importance of throughout the 36 years of my tenure, initially first 30 years with Vrunda Joglekar madam. She is my close friend. and she retired in 2018. So till 2018, we enjoyed statistics teaching because we discovered many activities, statistical activities. Like in our college, one day we used to select as an activity day. An activity day means on that day we used to collect different things, right from the latest alphabets, A, B, C, D, 26 pieces of alphabets, A, B, C, D, and so on up to Z. And we developed some games. Then we developed some games with the computers, like solitaire games. We associated some random variables and so on. And the students, like dictionary, for telephone dictionary, we associated with some, with dictionary also we, not dictionary, this telephone diary. Telephone diary, nowadays we do not have landlines. So that telephone diary or telephone means what is the importance of last digit, what is the importance of first digit of the landline number, etc. And of course the mobile number. But we even experimented with the dictionary, we even experimented with the telephone directory, etc. And we derived pleasure, and that gave an insight to both of us to look at the data. Means the teachers can also develop the insight for looking at the data, and they can supervise, they can teach the students. See, through the experimentation, we generate the data, and those data sets can be given as a practical examples also. In the practical class, we should give all real life examples. So I'm giving you some, my papers are published in some journals like Teaching Statistics, etc. So I'm giving you some examples of sports data from my paper also, so that it may motivate you to use statistics to other tournaments, sports data. Students can come up for analyzing, say, data sets. Data sets are not available directly from sports tournaments. You have to search, you have to take a lens and look at the data. So data sets are available in the tournaments, football tournament, cricket matches, etc. So how to scrutinize the data, how to develop the data sets, and once the data sets are available, how to use the treatment, statistical treatment. So that I'm showing. So it is a fun-filled teaching learning experience for both of us, and you can also experience that. It helps to understand the subject and helps in knowing the applicability of statistics. Of course, we both were, I am still involved, and we both were involved in popularizing the subject, because our subject is so beautiful. It is so applied that no subject can, every subject depends on our subject, because no research paper is published without a proper statistical analysis in every discipline. So this is such an important subject, and we should learn it in a fun-filled manner. Now, some interesting findings I will present. Why do some trees tilt towards left or right? Why do some trees tilt left or right? So a statistical study was conducted in ISI. Statistical study was conducted by Davis in ISI, and it was found that lefty trees are 10% more productive. Now, friends, dear students, I think in the first year you have studied observational studies and controlled experiments. Now, one can take up this as an observational study. Really, is it so? Lefty trees are 10% more productive. I hope that your college has a beautiful campus. There may be many trees. So this can be an observational study, whether lefty trees are 10% more productive. You can visit some mango or some fruits farms, and we can just take up this as an observational study. Now, friends, you must be, all of you students, you must be knowing Florence Nightingale, Lady with a Lamp. So I want to put her example here, because she was a nurse, a pioneer of nursing, and a reformer of hospital sanitization methods. She was appointed in a on a war front, and there she was doing nursing. She noticed that the main reason for deaths of army persons is not the war, but unhygienic surroundings. And she proved that. She developed a polar diagram And with the help of that polar diagram and some descriptive statistics, she proved that the deaths in the army persons is not due to war, but due to unhygienic surroundings at that time. And for most of her 90 years, Nightingale pushed for reform of the British military healthcare system. And with that, the profession of nursing started to gain the respect it deserved. Her use of new techniques. She developed a polar area diagram to dramatize the needless deaths caused by unsanitary conditions and the need for reform. With her analysis, she proved she revolutionized the idea that social phenomena could be objectively measured and subjected to mathematical analysis. And it is important that she was in nursing profession, but she demonstrated statistics and provided organized way of learning and led to improvements in medical and surgical practices. So she also developed model hospital statistical form for hospitals, and because of which she became a fellow of, imagine that a nurse, a person in nursing, becoming a fellow of Royal Statistical Society in 1858 and an honorary member of American Statistical Association in 1874. Carl Pearson acknowledged Nightingale as prophetess in the development of applied statistics. So, means what? If you are aware of what type of data are available, and if you just collect the data for your observation, and then if you analyze it properly, you can come up with an objective, you can come up with some outcome which is important for the community. So Nightingale's example is, I think, very, very open and it suggests that simple statistical applied statistics means just the basic statistics, descriptive statistics is also useful to arrive at an important outcome. Now, the second example is in the statistical linguistics. You know that, do you know that in one linguistics, statistics can be applied? So all of you know the two plays of Shakespeare, Love's Labour Lost and Comedy of Errors. These are very, very favorite, or very famous plays written by Shakespeare. But the period in which these two plays were written was not known. People were not sure about the period in which these plays were written. So Mr. Yadi, he took up this as a challenge for the society, and he studied the frequency distribution of certain words and certain phrases, sentences used in the plays, and compared at that time what type of phrases were used. You know that English people, they use the, and Americans, they just avoid the, THE. So there are styles by different writers, and he studied the frequency distribution of words and certain phrases, and then he concluded that this Comedy of Errors, it was written in the winter of 1591-92, and Love's Labour Lost, that play was written in the spring season of 1591-92. So how correctly he guessed? Because he studied the data carefully and then he came up with the correct conclusion. Now we are coming to the classroom experimentation. Now this is our habit. As I told you that on our activity day, we used to bring say rose flowers, simple rose flowers, and those we used to purchase, say, in kgs or 2 kgs, 3 kgs, and on that activity day, the flowers, such type of experiments were conducted. So I'm just presenting you one classroom simple experiment, that if you bring 1 kg of rose flowers and ask each student to pick up handful of flowers, in one hand, how many flowers can be? Simple. Once only he has to pick up the flowers. So in one hand, how many flowers are collected? That can also be a variable. Number of flowers in per hand, number of flowers collected per hand. Okay. What type of variable it is? Discrete or continuous? Can I ask? Okay, but your mics are muted, I think. So we can start from here. If you collect number of flowers per hand, then see, your statistical analysis, the basic step starts from here. What is the characteristic under study? Is it a variable or is it an attribute? If it is a variable, then is it a discrete variable, continuous variable? So here, ask the students count and note how many flowers collected per hand. Then count and note number of petals. It's a time-consuming thing, but it's an activity day. So count and note number of petals per flowers among the selected. But it's a fun field. What you are spending time. But if you are knowing that, if after conducting this experiment you are coming out with some data, then one can conduct such type of experiment. Now, what is the statistical treatment to this type of experiment? So you can form a frequency distribution of number of flowers picked per hand, the number of petals per flower. That is also a frequency distribution you can form for these two variables, and then observe the frequency distribution for any patterns. You can draw polygons. You can just look at your frequency distribution. Can you guess for some patterns? Use descriptive statistics. You can find mean, mode, median, etc. Okay. You can use some graphic representation and जैसे आप तुम लोगों का ट्रेजर हंट रहता है, एक क्लू मिलता है, उससे आगे का मिलता है. तो यहाँ पे डिस्क्रिप्टिव स्टैटिस्टिक्स इज लाइक अ क्लू. इन डिस्क्रिप्टिव स्टैटिस्टिक्स, इफ यू prepare the data sets correctly, then you can use the descriptive statistics to have some clue about is there any possibility of inferential statistics. So simple experiment for first year students, I can say, beginners. Then classroom experiment, another is that there are trees outside the campus. So select any such tree and randomly pick up the leaves. Why randomly pick up the leaves from the tree? Because if you pick up randomly the tree, the leaves, there is a possibility that length of the leaf may vary. If you pluck the leaves, then what will happen? It's all leaves may be grown up, and there may not be any variability. So randomly, if you pick up the leaves from the tree, there is a possibility that the leaf length may vary. And here leaf length may be a variable. So measure and note down the length of each leaf with a measuring instrument. Correct measuring instrument you have to use. Then prepare a frequency distribution of length of leaves. So here I am introducing a continuous variable. So you can have a group frequency distribution. You can draw histogram, find mean, mode, and median, and any guess if mean is very close to median, if it is very close to mode, if mean, mode, median are very, very close, and if the histogram looks symmetric, more or less symmetric, then any guess about the frequency distribution of length of leaves. It can be, if the histogram is symmetric, mean, mode, and median are very, very close, then there is a doubt, there is an intuition you can form about is normal distribution appropriate for this data, because the spread looks symmetric. And from this descriptive statistics, you will get some clue to develop the idea about fitting a probability distribution, maybe a normal probability distribution, and then your claim can be then verified using a chi-square test of goodness of fit. So एक के बाद एक ऐसे बराबर एक क्लू देगा नेक्स्ट क्लू को, नेक्स्ट क्लू देगा नेक्स्ट क्लू को. तो मुझे हमेशा ट्रेजर हंट गेम की याद आती है when we deal with data sets. Okay, so the third experiment is this we have conducted, and it was many like foot length, arm length, forearm length, arm length of individuals. We collected data, and this paper this paper was published in the National Journal in the name of Vrinda Joglekar and I. So this was a paper in National Journal, but what I can say that foot length, arm length, this we can conduct actually. For each paired data sets, you can generate foot length, arm length, like forearm length, arm length. So two variables I am introducing: foot length, arm length, forearm length, and arm length in centimeters. So ask students to take measurements on number one, this foot length and arm length in centimeters, and forearm length and arm length in centimeters. Collect the paired data in 1 and 2 for at least 70 to 80 students. We collected it for large number of students, but this can be done for 70 to 80 students. So you have the paired data. Find correlation coefficient between them, then test the significance. Once you See, for correlation, you need not declare a dependent variable and independent variable. You need two variables and you need to study the relationship. So if you study the relationship, if you find the correlation coefficient, then the next step is whether it is significant or not. So you can use the t-test for significance of this sample correlation coefficient. And if it is found to be significant, then you go to develop the functional relationship. Now, what is the usefulness of such study? You may say that this is very common thing and what is there, but its usefulness is such a study can be used in postmortem analysis. Postmortem analysis mein kaise hoga? Because when the body, when in an accident or in the say bomb blast, etc., the dead bodies, they might have lost hand, then foot, etc. Some parts of the body are missing. Then to guess what is the size and shape of that body and to identify the body, this forensic science has some analysis. So such type of analysis which we are doing is helpful to them in the forensic science. Then to design implants, operations जो होते हैं, orthopedic surgery जो होती है, उसमें अगर foot length या arm length या foot कुछ use करनी है, उतना implant करना है. So this functional relationship will help the doctors, even orthopedic doctors, to design implants. So such a simple classroom experiment has such a important outcomes. Okay, community useful outcomes. So here one should say that what are we doing, what experiments we are doing, and what is its application. That also one can think. But पहले experiment करते वक्त application मत ढूंढो, पहले तो ढूंढो कि पहले अपने को data analyze where our direction of data analysis is correct or not. And then definitely there are some applications. You must think of applications. So since we have given the applications and given examples, this paper was accepted in a national journal. Then there was one basketball player in our class, whose name was John. He was a good basketball player. So this field experiment was planned with him. He was ready to make the free throws. So John was asked to attempt a basket from 500 free throws. So 500 free throws in all he has done. But 5 free throws ka ek experiment kya. Means he throws the basket, he throws the ball in the basket 5 times in continuation. That is taken as one experiment. And the variable of interest here is the number of baskets in every 5 throws. So he made 5 throws and the number of baskets in the 5 free throws, that is counted. Then he then conducts next 5 throws. Then the number of baskets in the next 5 throws, that is noted. Aise usne in succession he continued 500 free throws. Of course, in between he drank water, some juice, etc. A whole team of students was on the ground, and they were interested in cheering John to continue with the experiment. So it was a wonderful day for all of us. What happened? The analysis was that the data were collected and the analysis is presented here. It is a simply first they calculated. Students were asked to calculate mean and variance of the random variable, and mean was found to be greater than variance. So estimated value of P was found, and that was 0.31. And the claim was number of baskets in 5 free throws can be considered to follow binomial distribution. Okay. Now, friends, here trials should be independent. So that independence is kept because John only threw the ball, and after some independence means after there were some gaps for making the attempts independent, homogeneous, etc. So claim was that number of baskets in 5 throws can be considered to follow binomial distribution with this estimated value of PS 0.31. Okay. So then this frequency distribution, the binomial distribution was fitted to the frequency distribution. expected frequencies were found, and chi-square test for goodness of fit was carried out. And the p-value was very large, so it was accepted that number of free throws in the number of baskets in the 5 free throws can be considered to follow binomial distribution. Now, the byproduct of this experiment is used, byproduct of this data, that was that we could explain the statistical definition of probability. What is the statistical definition of probability? When I say in the class that it is the, if you go on conducting the trials which result in only 2 outcomes, say large number of times, then limit as n tending to infinity m by n is the probability of event A. The event in which you are interested, you are calling as success. And you go on tossing, say, for example, if you go on tossing the coin set 500 times, then limit as n 500,000 times, then limit as n tending to infinity, m by n, this ratio is equal to will give you the probability of head, the probability of the success. If I say that, then the students may say that, wow, you have to consider the experiment so many times, you have to take limit. So the interest is lost. But here in this experiment, what we did, we asked them to classify the data like this. So after 25 throws, how many baskets, relative frequency was calculated. Then after 50 throws, total cumulative baskets 18, and the relative frequency is 0.36. As if after up to 500 throws, they collected the number of, they obtained the number of baskets, and the relative frequency was calculated. And then they plotted this against the throw number of throws from 25 to say 500, and they plotted the relative frequency on y-axis. Students, can you see that this graph, it stabilizes to 0.31 finally. It stabilizes to the value 0.31. Means if we could have conducted the trial, say 600 times, 600 free throws or 700 free throws, you could see the line exactly matching with 0.31, stabilizing over the value 31. So what is the outcome of this experiment? It can be observed that the empirical probability, we have taken estimated value of a basket, probability of a basket as 0.31 and fitted the binomial distribution. But diagrammatically, this graphically also, it can be observed that the empirical probability of a basket slowly approaches to 0.31 as the number of throws go on increasing. So this is nothing but the statistical definition of probability. So an experiment when conducted can show the outcomes of an experiment can be used to study another concept also. Then I gave one project to, this is a field experiment. I gave one project to my students for understanding the concepts in sampling and its effectiveness. Can you see the Super Bazaar here? So there is a Purti Super Bazaar in Nagpur, and we have chosen the 25th December, the holiday, 25th December, the Christmas day, as visiting the Super Bazaar. I talked to the owner of the manager of the Super Bazaar, and I asked him to allow our students to sit outside the Super Bazaar and do the observations, to take the observations. So he agreed. So what the experiment was planned. So you have to plan the experiment. So planning the experiment is what? Our aim is to estimate the average sale of the supermarket on that day. That can be easily calculated because the supermarket has a computer, and the clients were received the computerized bill, etc. So at the end of the day, the supermarket owner or the manager, he could find out the average sale of that day. But our aim was to prove it. How close we can estimate it by taking a sample. And here we use systematic sampling. So we selected the data on 25th December, say. Then the students prepared sheets, and it was a team effort because they sat there. The supermarket opened at 8 a.m. So from 8 a.m. to 10 p.m. in the evening. So 8 a.m. in the morning to 10 p.m. in the evening, there were different students, they were doing duty. Say each team, say 2 hours duty for each team, because it needed a lot of concentration. So they did the team did the work very nicely. Team efforts were praiseworthy. And how the systematic sampling was used. Say suppose it a random start, suppose the first customer entered, then they have given the chit to that customer, and they noted the time of entering the supermarket. So the time and the chit number 1, first customer, name is not important, number 1 and the time of entry, and the chit was given to the customer, and he was requested to write his time at the counter when he comes to the counter for payment. So he was requested politely to write the time at the counter and the amount spent. Amount spent can be written. If he has not written the amount spent, then from the bill the students used to write. They used to check whether the amount is written or not. But as a byproduct of the survey, another observation they have taken as time spent and the amount spent. It's a very, very interesting thing, that amount spent, time spent in the super bazaar and the amount spent. Is there any relation? Is there any correlation? So that also I asked them to note. So they used to note the entry time, and the customer entered the exit time. That is the time at which he or she reached at the counter. And they used to write the expenses, amount spent. So first customer if entered, then after that 10th customer, there is a space, equally space units were selected. So uske baad ka 10th customer, so 10th customer, the same thing is done. The number 10 is introduced, number 10 is entered, and the entry time is noted, and the same data were noted for first, 10th, 28th, 38th, 48th, and so on till 10 p.m. And objective to estimate the average sale per day. Lekin correlation between time spent in purchasing and amount spent. Okay, this was a counterintuitive observation कि हम कर ही रहे तो ये भी नोट कर लेते हैं. And estimation of average sale of the supermarket on that day. So ये मैंने इसलिए दिया था उनको क्योंकि supermarket owner or supermarket manager has this amount for the whole day. That is, population value was known, average sale of the supermarket on that selected day, mu, that average sale was known because that can be taken from calculated from the data entered in the computer. And the average sale of the supermarket calculated from the sample chosen by the student. And the conclusions were very, very close. I'm happy to share with you that the students did the work so nicely that they estimated the average sale of the supermarket very, very close. So point estimation was done, but very, very closely they could estimate. And they were happy because once you say that the sample mean is an unbiased estimator for the population mean, you are proving it mathematically. But when you observe it experimentally and when you are coming so close to the population parameter, they are actually understanding what is the importance of sampling, when systematic sampling is used, because we used to produce very few examples of systematic sampling. So I feel that I use this particular field experiment to understand the concept of sampling. And they were happy because the whole day they spent the whole day and they were very happy to share with me. And another important thing is correlation between what do you feel ki more you spend the time, more will be the amount spent. But no, the result was exactly opposite. Correlation was negative. The time spent in the purchasing and the amount spent. More the time spent, smaller is the amount spent. That was the very interesting conclusion there. And then we thought that it was 25th December, so people used to enjoy what type of things available in the supermarket. They may not be interested in purchasing. So that may be the logical reason we can give. And it was a negative correlation. So that was surprising for us. It's surprising in the sense if it was a summer में क्या है, ACs चलते हैं, तो ACs चलते हैं तो बहुत सारे लोग दोपहर में ब्राउजिंग करने के लिए सुपरमार्केट में जाते हैं, and they will not spend anything. But it was 25th December, so that's why it was surprising. Now, all these examples which I have shown you, experiential learning examples. So here we can develop the concept of variable or attribute. Are we dealing with a variable or are we dealing with an attribute? Attribute is a characteristic which is not measurable in terms of, it cannot be measurable. And variable is a thing which varies and which is measurable. You can take measurements on variable, you cannot take measurements on attribute. Okay, you can classify attribute, but you cannot take measurement. So first thing is you should be able to understand whether the characteristic under study is a variable or attribute. Then if it is a variable, then you have to understand that whether it is a discrete variable or continuous variable. Accordingly, you have to form a discrete or continuous frequency distribution. Then concept of descriptive statistics comes in picture. If it is a discrete frequency distribution, then हमको क्या करना है, polygon वगैरह निकाल सकते हैं, then mean, mode, median वगैरह, all these things are possible. If it is a group frequency distribution, then you can have a histogram, you can check for some patterns, can we fit some probability distribution, etc., etc. And student can learn fitting of theoretical probability distribution, chi-square test of goodness of fit. ये जो concepts हैं, उसके लिए ये experiments, if you conduct, we have seen the joy on students' face and the knowledge enrichment which they had. So concept of statistical definition of probability also we could explain with this, and understanding of concept of sampling techniques. So through these experiential learning, these simple concepts are clear. Now I'm presenting you my paper on figuring out statistics of the ICC World Cup 2011, published in Teaching Statistics Journal, International Journal, Teaching Statistics. This journal encourages papers with analysis that is useful in classroom teaching. So here are the data sets of the results of the matches played in ICC World Cup. I thank my guide, Dr. M.N. Deshpande. He expired recently, but he worked as a catalyst for all of us, all his research students, because he is aware of all data sets. So election analysis, all these things I did with him. He was very inspiring personality, and I did many election analysis and projections, etc., and enjoyed that analysis with him. So this paper is with Dr. M.N. Deshpande. My paper is with Dr. M.N. Deshpande. So the data sets of the results of the matches played in ICC World Cup can be gleaned by using statistical eagle's eye. Now you have to take a lens to look at data, that I used to tell to my students, because जैसे घर में नौकरानी आती हैं, वो फटाफट झाड़ू लगा देती हैं, but when you do that, when नौकरानी नहीं आती और तुम लोग झाड़ू लगाते हो, तो कैसे करोगे? कारपेट के नीचे से, यहाँ से वहां से कैसे लेते हो? वैसे you have to look at the data with a lens, and ऐसे ऊपर ही ऊपर देख के नहीं चलेगा. So if you look at if you enjoy the matches, then you can think of say creating data sets out of the statistics of matches. So the data sets and the methods of analysis will be useful when given as a classroom assignment to students while teaching in applications of statistical tools. So here teachers are also there. So I can tell you that I am using these data sets created from this ICC World Cup 2011 in my fitting of Poisson distribution practical, fitting of normal distribution practical. And the students, they read the data and they say that, oh, it's World Cup data. So it's a real life data. So Poisson distribution, fitting, goodness of fit, etc. we can do on such data sets. So structure of ICC 2011 World Cup matches, 14 countries participated. These 14 teams were divided into two groups, A and B, and there were relatively four strong and 3 weak teams in each group. That is 7 teams in A, 7 teams in B. Out of 7 teams, 4 strong teams and 3 weak teams are there. And in all, 49 matches were played and 42 league matches and 4 quarterfinals, 2 semifinals and 1 final. But 1 league match was washed out due to rain. So the analysis deals with 48 matches, not 49, 48 matches, that is 96 innings. Now here we studied some rare events, and you know that Poisson distribution is generally applicable in case of rare events because P should be very, very small and N should be large. So here P should be very, very small means what? Probability of occurrence of that event is rare. So we studied, we just found out some rare events and we collected the frequency distribution of these events and we fitted Poisson distribution. So just wanted to share with you first, such type of intuitions are there that if you win the toss, अपने Indian captain ने toss win किया, चलो अपन अब जीतेंगे. So this is an intuition, people's intuition. कि does winning a toss affect the result of the match? Affect करता है क्या? But you are a statistician. Every claim, every intuition can be converted into an experiment, can be converted into a claim, and can be tested with a proper statistical analysis. So, a question that was the question raised during these matches. So, we collected the data. Here, there were 47 matches in which won the match and won the toss, winning the toss and winning the match 22 the, winning the toss and losing the match में 25 the. Okay, so proportion test was conducted, was used, single proportion, and there is no such evidence that because the p value was quite high, p value was high, and therefore we could say that there is no evidence that winning the toss necessarily leads to victory. Then the same thing, कि decision after winning the toss, if you take first batting तो जीत रहे हैं या first bowling लेके जीत रहे हैं. So many people believe that decision after winning the toss, batting पहले ली, because chase करने में थोड़ा सा pressure रहता है. So many watchers, cricket lovers, they believe that after winning, if batting पहले लिया तो जीतने का chance ज़्यादा है. So we tested that also. A decision after winning the toss, batting first, bowling first, and after result of the match is winning the match or losing the match. So you can get a 2x2 table, and you can consider whether the winning decision after winning the toss it is associated with the result of the match. So chi-square test you can consider, and we can get the p-value as 0.559, which is very high, and whether the decision after winning the toss affected. That was the question, but the result is with you because the p-value of the test is quite high, 0.559. Then we classified the matches played into three types of teams: strong versus strong team, strong versus weak or weak versus strong team, and weak versus weak team. Why? Because we have to consider 4 rare events, say number of sixers. Sixers क्या होता है? If a weak team plays with strong team, the strong team बहुत runs बना लेती है because the opposite team is weak. So we just omitted these SW or WS team and WW team, and we consider for some events only the strong versus strong matches. So in every match, पहला event था, I think all students are familiar with the word power play. Power play is a term coined for first 10 overs in an inning in order to promote the attacking play from the batsman. So the fielders were restricted. Okay, in order to promote the attacking game, the fielders were not in front of the batsman. They are at far distance. So only for first 10 overs. So the first 10 overs, the batsman can take advantage of that, and therefore the number of wickets in the first 10 overs in the power play, that could be an interesting variable. So group frequency distribution of number of runs scored per inning in the first power play, according to when we studied this, we could get some 4 rare events, as I have already told. The first event was the number of wickets per inning in the first power play, because power play mein the batsman hits the ball and the fielders are not very close. So there is a chance that wicket may be there, but without falling the wicket, one can score good runs. So it's a possible event, but a rare event. So we collected the data on frequency distribution of number of wickets per inning in the first power play. for all the matches. And then we could fit the Poisson distribution. Poisson distribution, the p-value was 0.754. 4 and more karke, we fitted Poisson distribution and the p-value was 0.754. So the number of wickets lost in the first power play per inning can be considered to follow Poisson distribution. So likewise, we considered the distribution of number of runs, runouts. Runout is a rare event. So we considered the distribution of runouts per inning, second event botha. And here, can you say a classic? You can just look at the frequency distribution. 0 ki frequency 56, and then it tapers off to right side. So here we again claim was the Poisson distribution and the p-value was 0.55, and therefore Poisson distribution provides a good fit for this. Then the third variable was number of sixes hit per inning and number of maiden overs. Now iske liye humne wo sirf data liya strong versus strong, because number of sixes hit, if we consider, then weak team comes there, then the strong team scores many sixes and number of maiden overs are also there. So for this third and fourth variable, we considered only the, we divided the two teams in three types, SW, WW and SS, and we considered only the SS teams. So SS team ke 18 matches the, to 36 innings ke data ke liye humne the number of sixes and iska, and the frequency distributions are here. Number of sixes hit per here, and here there was a very marginal low p-value 0.092. So Poisson model is marginally accepted for number of sixes, and you can logically also you can see that number of sixes is not a rare event. जैसे ही ball weak मिलता है तो batsman 6 मार देता है. So that's why here Poisson model is marginally accepted with a low p-value. And then distribution of number of maiden overs also for 36 innings of SS teams we considered, and here the Poisson model is again accepted. Then the last variable was the run rate per over. So run rate per over, that was considered for all 95 innings, and you can see a beautiful picture of the frequency distribution. What is the case? You can see that the frequency is increasing up to this, and then it is coming down, almost 4 on both the sides. So it gives an intuition, histograms and all that. It gives an intuition that the normal probability distribution is perfect fit. So the question was, can the normal probability pattern be fitted to the distribution of run rate per over in the inning? So Anderson-Darling test is used for testing the normality, and you can see that the p-value is quite good, and we can see the histogram also, and you can see that mean, the value of mean 4.95 and the value of median also 4.8. Okay, quite close, and this can be accepted for symmetry, this type of histogram. Okay, and Anderson-Darling test p-value is 0.534, so fit is good. So normal distribution is justified for the run rate per over in this. Now, the analysis has some more things, but I am presenting this only for UGs to means basically the fitting part. How can you use the sports data for generating such data sets, and such data sets if we give in the practical class for fitting normal probability distribution or Poisson probability distribution, they are interesting data sets. So here, to study the agreement, one more thing I want to show. It gives you, in that tournament, the points table was prepared and the teams were actually ranked according to the points they scored. But we introduced another variable. What is that? Net run rate. This variable we introduced, and we obtained that the run rate per over for each team were available. So we put it in the second column, and we give the ranks, and then we found the rank correlation coefficient. So the teams in the two groups were ranked on the basis of points scored as well as their run rate by us. And the Spearman's rank correlation are then calculated. You can see that there is a good association between the points and the net run rate, because the Spearman's rank correlation for this group A also is good, fairly good, positive, and here it is, they both are fairly positive. So such type of analysis of sports data set, okay, can give us idea about large sample test for single proportion, equality of means of two populations, construction of confidence interval, chi-square test for independence of attributes, calculation of rank correlation coefficient. And such these data sets and their analysis may be useful in providing interesting examples for classroom teaching. That is what I feel. Then I already told you that I'm giving you one example of internet data. So I gave this example from the internet data. It was known as this experiment is known as a paper helicopter experiment by George Box. Okay, it is available on the internet. And I told the students that you take this experiment and generate the data for t-test. You must generate the data for t-test, and then you apply t-test and come out with the conclusion. So their job was consider this paper helicopter experiment. Data were not given there. Only paper helicopter experiment is given, and that is by George Box. So they consider that experiment and they carried out that experiment such that 2 sample test is applicable. So they were asked this, objective of study was this. What they did, they first found out the variable under study. The variable under study in that experiment was flight time in seconds. They identified the variable flight time in seconds. That is landing time. When you release that helicopter by hand, when it lands, that is known as flight time. So flight time in seconds is the variable under study. And the criterion for comparison, they were found out as an aspect ratio. That is rotor length upon rotor width and the type of paper. So I will show you what is meant by rotor length. This is rotor length and rotor width. So from which you can compute rotor length by rotor width. So that is aspect ratio. This is the body, this is the leg. Okay. So assumptions they have first they carried out they were very, very careful about the assumptions for small sample t-test. So they use the constant force to release the paper helicopter. Then the wind pressure was kept constant. Height from which the paper helicopter is released is kept constant, that is 254 centimeter. Body length was constant and leg length was constant. Observations on flight time of helicopters are independent. Why? Because every time new paper helicopter was released, they prepare 80 helicopters, paper helicopters. So every time since they use new helicopter, the observations on flight time of helicopters are independent. So these are all necessary conditions for the applicability of t-test. So when you plan an experiment, you have to make sure that are you assuming? See, there are two things, assuming and eliminating the things. So you must plan your experiment such that all assumptions and conditions for application of t-test or small sample test are true. All assumptions are true. So they have verified that they are satisfying all the assumptions of small sample t-test. Now, execution of experiment, what they did, they prepared 40 paper helicopters using chart paper and 40 paper helicopters using a print paper sheets. So chart paper, there is a difference of weight in these two papers. One is slightly thick and other is very thin. So they prepared 40 paper helicopters using chart paper and 40 helicopters using print paper. Out of 40 helicopters of chart paper, 20 were of aspect ratio 4. So aspect ratio is the another criteria. एक criteria of comparison है aspect ratio and other criteria of comparison is the width of the paper. So similar differentiation in aspect ratio was done for 40 helicopters made of print paper. So print paper में से 20 helicopters का aspect ratio 4 था, 20 का aspect ratio 2 था, like the hard paper means. So total of 80 helicopters are prepared. This is a view. You can see my students working. He's standing. He's Saurabh Gupta. And I'm happy to share with you that he is doing his MSc from Delhi University. From my college, he stood first in the national level entrance exam of Delhi University. His number was first number, and there also he got a good package. He's studying in same 4 now of PG MSc, but he got a very good package, and he's doing wonderfully. The second student, she is Kaumudi Giridhar, and she is studying in MS University Baroda, doing MSc Statistics. So by doing such experiments, and they are happy, and they create interest in the subject, and the program outcome is that they get admission in good institutes. So these 4 students, they conducted the experiment. They prepared these 20 helicopters of each type, and they release from this height. They used to release the helicopter, and these students, they used to take the observations. So the data collection can be by flying 20 helicopters of each of the 4 types. So you can see that the aspect ratio is 2:2 for chart. This is chart paper, print paper, chart paper, print paper. So aspect ratios are 4 and 2. And then comparison. So they conducted 4 t-tests. They generated the data set for 4 t-tests with aspect ratio 2 and 4 made up of chart paper, with aspect ratio 2 and 4 made up of print paper. तो यहाँ पे comparison क्या है? 2 and 4. Aspect ratio 2 and 4 made up of chart paper and aspect ratio 2 and 4 of print paper. So comparison between chart paper and print paper hai. With usage of light and heavy papers with aspect ratio constant rakha and light and heavy paper vary kiya. With aspect ratio 2 rakha and light and heavy paper ki comparison. And they could generate 20 observations of each, and then they carried out the t-test, then concluded with the inference. And this project, Dr. A.P. Gore gave this they presented this project in a national workshop where Dr. A.P. Gore was present, and he came forward and he clapped for them, and he said that this is a wonderful experiment which they have analyzed. That means from the internet experiment, they could generate the data sets, they could utilize the data for applicability of t-test, and they could carry out analysis with the conclusions. And this is what is expected from a graduate students. Okay. Now data are available on all walks of life, as already I have told. Market data are there, social science data are there. And they on 3rd March, I delivered a talk on significance of public response in national surveys in the NSSO. I delivered one talk on significance of public response in national surveys at the National Sample Survey Office on 3rd March, this month only. And the program was organized by the Ministry of Statistics and Program Implementation. And there also, they are saying, NSSO people are saying a lot of data are available on their sites. So one can use the government sites for data sets. Some data sets are open, some data sets are not open, but you can just visit different data sets, whether data sets are available. This official statistics I am referring. Carefully collected data can be studied and analyzed in detail, and these are presented in easily and understandable manner to create a great impact. So in the UG course of statistics, I feel that you need not go to the research papers and just study research papers and try to understand the research work of the eminent researchers. In UG course, you should aim at simple experiments, simple data collection, collecting the data sets accurately, and then analyzing it properly. That should be the objective. When you join PG and when you join PhD and all that, then at the PG level, you may study the research papers and research work, and you can you may get motivated to do that type of work. But at UG level, you need to understand such thing. Whether you go to data science, where you go to clinical research thereafter, this particular practice will help you a lot in your future. Okay, so this topic I have added just 5 minutes. I'm showing you interesting application of diagrams. Now you are all first year students. Are there some first year students, I think? So representing values, frequency This is done in the research analysis also, in the basic. Many researchers in other fields, we found that they used to come to us and they used to say that, madam, you please use pie diagram. But pie diagram, is it applicable or not? That is the job of statistician. Which diagram is perfect in which particular case? That is to be decided by the statistician. So just I want to tell you, we used to conduct statistica at many places, at least 20 places we have conducted. In Pala, Kerala also, we conducted at Pala, Dr. Jose, I think, K. Jose, he invited us to conduct StatStorm quiz at Pala also. So we went to even Kerala also for conducting our quiz or statistica. So there, we used to conduct the feedback on statistica. So एक question था कि उसमें usefulness of understanding statistics. Why statistics? What do you feel about opinion on statistica was useful in understanding statistics, highlights the applications of statistics. It gives information about statisticians, or it gives information about general knowledge in statistics. इसके लिए हमको feedback चाहिए रहता. तो हम written feedback we used to collect, and we have lot of data on these feedbacks. So just I'm presenting you data. This is a simple bar diagram where I'm getting that there are 190 students saying that it is useful in understanding statistics. 140 are saying highlights application in statistics. 150 students are saying the third thing, and 90 are saying that it gives information about general knowledge. Now, if I show you this diagram, this is a multiple bar diagram, and it gives the breakup. ये जो 190 है, that is 130 plus 60, means there are 60 females and 30 out of 190, 130 are male and 60 are female. Likewise, the same 140 total, here it is shown as 90 and 50 and so on. So this gives me gender wise comparison. तो अपने को देखना है अपने एनालिसिस में हमको जेंडर वाइज करना है क्या, नहीं है तो ये डायग्राम काम का ही नहीं है. दिस इज ओके. जेंडर वाइज करना है तो देन यू हैव टू शो. बट आई एम शोइंग यू इंटरेस्टिंग डायग्राम नेक्स्ट. सी हियर, हमारे वर्कशॉप में फीमेल्स या गर्ल्स कम ही होंगे. ये जो है यहाँ पे कम कम कम, इसका मतलब ये तो नहीं है कि गर्ल्स ने नहीं दिया है इस पे ज्यादा काम. गर्ल्स हैव नॉट गिवन द ओपिनियन ऑन दिस पर्टिकुलर एस्पेक्ट. ऐसा है क्या? देन आई शुड गो टू दिस कि कितने परसेंटेज वाइज क्या है, क्योंकि गर्ल्स कम होंगे अगर पार्टिसिपेंट में बॉयज ज्यादा है और गर्ल्स कम है तो. सो आई शुड टॉक अबाउट परसेंटेज. कितने परसेंटेज में कितने लोग फीमेल बोल रहे हैं और मेल बोल रहे हैं. सो इससे अच्छा क्या है, ये डायग्राम से अच्छा ये है, बिकॉज इट कैलकुलेट्स द परसेंटेज आउट ऑफ द टोटल गर्ल्स हु हैव सेड दैट. सो इट कैलकुलेट्स आउट ऑफ मेल एंड फीमेल, तुमको परसेंटेज मिल रहा है. सो दिस डायग्राम इज बेटर देन दिस. ओके. देन अभी ये डायग्राम जो है इसमें मुझे पता चल रहा है कि 10 टोटल 200 लोग आए थे. This is a subdivided diagram. So total 200 आए थे, 10 लोगों ने दिया ही नहीं है. Not only that, this is a surprising thing कि gives information on the general knowledge of statistics में 110 ने no opinion given by 110. This is shocking. So friends, dear students, on the say channels, different news channels, various surveys are conducted, and they often say that 80% of the people they prefer Modi ji. अरे but कितने लोगों ने, I'm not against or in favor of, I don't want to say anything about Modi ji, but I have an objection in their survey. As a statistician, you should first talk about how many attended. Like in today's webinar, how many are attending out of how many are attentive, वो percentage उसमें आएगा. But first you talk about the total. So यहाँ पे मुझे पता चल रहा है, ये डायग्राम मेरा पहला आना चाहिए कि इसमें इतने लोगों ने नहीं दिया था. यहाँ 102 लोगों ने नहीं दिया था. If you want a true opinion, this diagram, and then coming to this diagram. तो ये एक तो क्या है, opinion of statistica. ये परसेंटेज किससे निकाला है? 190 upon 200, 140 upon 200, 150 upon 200, and 90 upon 200. So unless I quote how many are attending my workshop, और उसमें से कितने लोगों ने इसको बोला है यूजफुल है करके, so that is that percentage. So this diagram is a simple bar diagram giving me percentage of students out of the total 200 saying that it is useful. So this is useful for me. This is more useful for me. And this also is useful for me if I talk about, if I want to know कि यहाँ पे कितने लोगों ने नहीं दिया है, percentage में if I calculate, तो 110 out of 200. So it comes out to be how much? This is the percentage who have not responded. So this diagram is the best because it gives me the percentage. It compares the male, female and not giving any opinion, and it gives me the overall picture. So this or this may be better. Okay. So with this, we are coming to end. That is basic data analysis guidelines. So as a student, when you collect the data, these are the basic steps in the flow chart. In flow chart time I'm giving, when you collect some data, you identify the characteristic under study. Then characteristic under study, when you identify, see whether it is an attribute or a variable. Decide, because why I'm saying, because if it is attribute, very limited data analysis is possible for an attribute. And for a variable, lot of branches are open. If you can assume, I always tell my students, when I teach them large sample test, non-parametric test, small sample test, then I tell them that when you want to cross the river, suppose you want to cross a river and bridge is available, so you will use bridge to cross the river. Likewise, when you are dealing with the samples, and the sample can be assumed to be drawn from a normally distributed population, you can assume or you can confirm that the sample is drawn from a normally distributed population. The whole branch of small sample test and whole ANOVA and all that, everything is available. So it is like bridge, getting a bridge for crossing the river. But suppose you do not have bridge to cross the river, then you will search for a boat to cross the river. So searching boat means what? Increasing the sample size. You cannot assume the normality for the sample. Sample cannot be assumed to be drawn from a normally distributed population. That is, bridge is not available. So you are searching boat. Boat means what? You try to increase the sample size, use central limit theorem and use the large sample test. Some approximate test you can have. But suppose boat bhi nahi hai, cross karne ke liye river, तो you will search for a piece of wood, tarafa जिसको बोलते हैं. तो piece of wood over which you can land and you can cross the river. That is nothing but non-parametric test. That is, you cannot assume normality for your sample. Sample cannot be assumed to be drawn from a normally distributed population. You cannot increase the sample size. Therefore, you cannot use large sample test, because nowadays clinical trials and such trials may increasing the sample size is not the solution. So if that is the test, that is the case, then in non-parametric test, there is no assumption about the distribution of the parent population. So those are, you lose accuracy, but somewhere you can cross the river. That is non-parametric test. So ऐसे अगर हमने classify करके देखा, तो we are in a better position to analyze the data. So attribute and variable में, attribute में बहुत limited data set है. Decide the type of primary, secondary method of data collection. Now in the pandemic mode, only the Google form method was available. But now we are open, we are meeting offline. So again, search for a good method which can give you good data, accurate data. Classify and tabulate. Attribute होगा तो तुमको tabulation, cross tables, percentage की निकाल सकते हो, diagrammatic representation use कर सकते हो. Attribute के लिए diagrammatic representation है, variable के लिए graphic है. So if it is an attribute, then limited data set, limited statistical treatment. You can find percentage, and percentage के लिए you can use large sample test for population proportions. If association वगैरह दिखा, Yule's coefficient वगैरह करके association दिखा, तो you can use chi-square test से confirm कर सकते हो. Homogeneity test, large sample test for single proportion, equality of two proportions. Such type of analysis only is available for attribute data. Now, if your characteristic is variable होगा तो discrete है कि continuous देखना है, then formation of a discrete and continuous frequency distribution देखना है. Discrete होगा तो polygons, simple bar diagram. Continuous होगा तो histogram, polygon. Then histogram से कुछ pattern दिख रहा है क्या? Intuition. Are you getting some intuition for the form of the distribution? Then अगर दिख रहा है symmetry आ रही है तो देखना है mean mode median same है क्या, यानी और ज्यादा उसको स्ट्रांग बनाना है, सो यूज डिस्क्रिप्टिव स्टैटिस्टिक्स, मीन मोड मीडियन है, कोरिलेशन है, कुछ भी तुमको जो करना है कर सकते हो. देन यहाँ पे आता है इन्फरेंशियल स्टैटिस्टिक्स. यहाँ पे बहुत सारे दरवाजे बंद हो सकते हैं, क्योंकि इफ योर सैंपल कैन नॉट बी अज्यूम टू बी ड्रॉन फ्रॉम अ नॉर्मली डिस्ट्रीब्यूटेड पॉपुलेशन अगेन, तो तुमको वो लार्ज सैंपल टेस्ट है और इंक्रीज नहीं कर सकते. अगर लार्ज सैंपल टेस्ट नहीं तो फिर नॉन पैरामेट्रिक टेस्ट की तरफ जा सकते. तो कौन से दरवाजे ओपन है, कौन से दरवाजे बंद है, यहाँ पे इन्फरेंशियल एनालिसिस में लॉट ऑफ थिंग्स यू हैव टू डू. ओके, सो experiential learning, I think that it makes a lot of difference. Teaching statistics through experimentation and activity-based learning enriches the students as well as teachers. The teacher also develops an insight. We found that through these experiments, through these projects, we developed an insight at looking at the data, and that's why we could do consultancy for at least 15, 16 projects. Now also I'm receiving many phone calls, but now I'm alone, the only member in my department. I have a lot of things to do, and I have promoted to professor, but right now I'm engaging almost 30 classes because my students are so good that I feel that I should not, because we do not get contributories without set net or PhD, and there is a what you can say, lot of thing. Comment is not means we have given as a head statistics group, everyone, I'm on head statistics group, everyone feels that for contributory teachers this set net PhD should not be done, at least for statistics, because in statistics the motivation for doing PhD is day by day decreasing because of this bad practice. And that's why in my college I am not able to conduct so many projects now, but still I feel that I should conduct some experiments which are very important from community point of view. Like some farmer, I should collaborate with some farmers and do some research and do some with the help of students, and conduct some experiments which are applicable to community. Let us see how it can work. But I feel that the teacher also develops an insight for data analysis. This is my own experience. Mathematically, the definitions, basic concepts, and simple statistical techniques taught in the undergraduate syllabus of statistics can be effectively and interestingly taught, exposing the students to live data. Okay, and live data sets are there, but we have to find out. That is the thing. The modern statistics education emphasizes the application of tangible and interesting example, which creates the students' interest about the statistical concept. And I can see that we can make our statistics class very meaningful, very fruitful. And even if you take 2 or 3 long classes, you can conduct some experiment in one class and you can make it more interactive, more say happening class. So class material for introductory and advanced statistics can be colorfully illustrated by using appropriate data sets and examples from real life data. As Harshini said, this book is slightly delayed because we released it in our workshop, but there were some corrections that we found after that, and we just sent that to our publisher. But he has taken a lot of time, and now he told me that it will be available soon on Amazon. So if some students are interested, I will send its link when it is available. I'm not sure, but say within 15 days, if it is available, I will send the link to Dr. Vijayashri so that she can share and you can order it from there. So here in this book, we have expressed, we have suggested, we have presented at least 24 structured analysis of 24 examples, field and classroom examples. And the examples which I have given, they are not there in the book. They are all very good examples, and you will enjoy. Even teachers will enjoy this book, reading this book. And we have suggested some, in the last chapter, we have suggested some exercises and suggested the statistical treatment also. So this book will be soon available, let us hope, and I will be able to forward its link to Dr. Vijayashri. So friends, I want to say that statistics has no fruits. Statistics has no roots without other disciplines, and no discipline has fruits without statistics. So this you must keep in mind. And thank you. If there is any query, I'm ready to answer.
Thank you so much, ma'am, for making us understand statistics in an experiential way. You are such an inspiration for us, especially for us statistics students after hearing about your research papers and about your professional background. So today you made us know how much it is easy to understand statistics in an experiential way with such easy examples like roses and trees. You also brought in sports, like personally, I'm a fan of cricket. So as you said, whenever I watch cricket, I'll be like, okay, India won the toss. Say, for example, we take India. India won the toss. Maybe they'll choose batting or bowling. When the super over is like complete, I'll be like, this score is good. Okay, not bad. Or what are they playing? This is not good at all. Like, jokes apart. So after hearing about your research, so whenever I watch cricket, I'll be like, okay, Jyoti ma'am said that we can analyze cricket in an experiential way, not cricket, like analyze things in an experiential way. So thank you so much, ma'am, again. So I hope many of our students have already come up with a lot of questions to ask to you, ma'am. So we request you to answer them. Students can post your questions in the chat box.
Hello, I can see one question. Can you repeat? Can some of you can read the question? Hello, Harshini or Kavya, can you read the questions?
Yes, ma'am. I'll do that. So we have a question from Raghavishri. Yes, ma'am. Her question is, ma'am, can we make assumptions for the experiment even if they might not always be the reality?
No, you cannot make assumptions. That is what I am saying, that you have to like say मैं बच्चों को बताती हूँ कि चोर assume कर रहा है कि मुझे कोई नहीं देख रहा है और चोरी कर रहा है, तो क्या होगा? वो पकड़ा जाएगा. But if he makes it clear कि nobody is watching him, तो वो चोरी करके जाएगा. So assuming the assumptions and making it clear. जैसे मैंने अभी एक experiment बताया जो इंटरनेट का experiment था. Have you seen that how the assumptions are first clarified? कि हमारा experiment, is our experiment satisfying the assumptions? So you have to make sure that the assumptions are true or not. Okay. I think my answer is clear.
Hope it is clear, ma'am. Actually, I hope Raghavi's doubt is also clear.
मैंने ये बताया है कि अगर if you cannot confirm normality, then you increase the sample size. You can use sample test, etc.
Ma'am, sorry to disturb, but can you please make it in English because Hindi is not so comfortable. Many of us are Tamilians here.
Okay.
So
see, I told you in my talk that if you cannot assume normality, like the example which I have presented, say paper helicopter experiment, there I have made clear that they have clarified that they are following the assumptions of that are important for t-test, application of t-test. Like they prepared 80 helicopters. So every observation is independent of each other. Observations are independent. Then they have used the test also. Means the sample jo 20 observations aaya na, I forgot to tell you that they have used the test for normality. There is a Anderson-Darling test also available in Minitab, available in, you must be using R. So in R also, there are tests available for testing normality. So they have used these for all their 4 data sets. They have used the normality test, non-parametric test they have used for normality. And they have clarified, they have verified that the p-value is large and normality is accepted, and then only they conducted the t-test. So it is better you have to check the assumptions. And assumptions are not satisfied. Suppose for t-test, strong assumptions are the sample should be drawn from normality. If there are 2 samples, then the sample should be independent, etc., etc. So in that experiment, I have shown you how to check for the assumptions. Okay. And you cannot assume, you have to verify whether you have means you have assumed, whatever you have assumed, that is really true. You have to make sure that the assumptions are true, and then only you can carry out that analysis. Otherwise, what will happen if you are writing the writing a paper? Queries will come. Have you tested for normality? How are you assuming independence? So you should not assume. You should make it confirm. You have to confirm whether independence can be assumed or not. Okay. Otherwise, that technique you cannot use. I think I'm
Okay,
not
ma'am.
clear.
Yes, ma'am, you are clear, ma'am. She also cleared her doubt. We have next question by H. Satikavarsa. Given the fact that statistics has multi-dimensional applications, do you think statistics can also be taught as a fictional subject?
Statistics can also be taught as?
Occasional subject.
Oh, that is a good thing. And in the credit-based syllabus, a biology person should actually learn statistics, because now all subjects have applications. All subjects need statistics. So autonomous universities are nowadays developing the add-on or certificate courses. So it should be made mandatory to mandatory, or say availability of a statistics course for other disciplines is very good initiative by autonomous schools. And applicability nowadays in data science, they are means they do not want engineers, they want statisticians. So that's why other people, they are learning statistics course and they are getting jobs. So it's a danger for statisticians. They are not understanding the applications of statistics.
True, ma'am. Okay. So, ma'am, there is another question from her. So, can the method of association of attributes to answer, does winning a toss affect the result of the match?
Yes, it can be, but see, it's what you can say. It gives you a value, a particular value. It can be used, but when you are using an inferential analysis, you are providing a p-value for your statement. Okay, your test is, you are carrying out a test and you are supporting to the support. For supporting that, you can give a p-value. Another thing is, if you find out a proportion test, you can provide the confidence interval. Okay, so association, Yule's coefficient association can be used, but when the inferential analysis is possible, then I think you should go for chi-square test, and one can quote the p-value along with that. Okay.
Okay.
I think that Yule's coefficient of association is a first step, and then it should be followed by chi-square test for independence.
Okay, ma'am. So we'll go to the next question by Afrin. So in an experiment, if the observations are so extreme, which may lead to a false result, what can we do in such situations?
Okay, for that I will suggest that descriptive statistics as a box plot. Okay, the graph, one of the graphs is a box plot. So you should be able to identify the outliers with the help of box plot. And outliers, if there are too many outliers and your observations are say 30 or 40, and there are 10 outliers, then definitely you will be losing data. So then you have a heterogeneous data. For example, I want to quote one example, that a particular, it's a very interesting example that I give in my class, and that is a particular person, say take name John. John wants to join a swimming club, and he's a good swimmer, but his expectation is that he wants to join a swimming club where his age people are there, so he can get a company of his age people. So he visits one swimming pool where board was written average age of swimmer is 23, and John is of age 23 or 24. So he found that average age of the swimmer is 23, so this pool is best for me. So he just registers his name, and when he registers his name and he goes to swimming, he joins a batch, he finds that there is no one of his age, because 35, 36, 37 age ke papa, fathers of in the age group 35, 36, 37, and children, and their children in the age group 6, 7, 8. Just calculate the mean. If you pull them together, the mean is 23. So you should not do this mistake. So that's why the age was 23, and John was very unhappy. John is unhappy because he could not get anyone of his age. And that was the mistake of statistician, who added all the ages and divided by the total number. So his answer was 23, whereas it was not a representative value. So in your data set, if there is too much variability, you try to divide it into number of groups. Say you have learned stratified sampling. So you divide them into different groups and just see that within a group, there should be homogeneity, between groups there should be heterogeneity. And then can you give separate treatment to separate groups or not? But don't, dealing with such heterogeneous data set is very, very dangerous. You may come up with such false result. जैसे मैंने बताया कि what I have told, that John is unhappy because he could not get anyone of his age. I think you got the answer. If there are 1 or 2 outliers, you can get rid of them in the beginning by drawing a box plot. Usme outliers will be visible, and you can, if 2 or 3 outcomes are, if 2 or 3 observations are very, very far, you can delete them, and suppose 100 observations at 3 are outside, you will get only 97, and the 3 can be deleted in the beginning only. Like I have deleted one match that is washed out. Okay. In my analysis for cricket. Okay. Any?
Yes, ma'am. We have one.
I think I'm answering them in a means they are understanding what I'm telling.
Yes, ma'am. Yes, ma'am. They are understanding, and they have been messaging that they have been understanding it.
Okay, good.
Yes.
Yes. Good afternoon, ma'am.
Yes.
Ma'am, so I have a feedback. I mean, okay, it's not a feedback, but I have a thought, and I want to know if I'm correct in assuming it. So, ma'am, in your presentation, you shared a bar graph about opinion of students on Statistica.
Yes.
And ma'am, you were visibly unhappy about about 110 people not opting for the last option, gives information about general knowledge on statistics.
Yes.
So, ma'am, okay, maybe I am wrong in assuming it, but I think all the 4 options given here are like when a person clicks the G form and sort of reads all the options, most of it sounds the same. So maybe that's why people didn't click all the options, because they thought one represents the other.
No, Harshini, they are one below the other. It's not a Google form. It's a what you can say.
Google form. MCQ.
It's a hard copy, and not in the one option. Not in one option. All these are used. Say yes, no type ke. How many do you feel that it is useful in understanding statistics? Do you feel that this is highlighting essay type K? So those people are, you are saying that what you are saying that I can understand, they may be saying that we have already responded. And see, when the program is finished, when offline program, Statistica workshop is conducted for 2 days, fruitful workshop. It has 3 lectures. We used to deliver lectures on different aspects like clinical trials, rewarding careers with statistics as one of the subject, etc., different topics, and lot of competitions. In this particular Statistica, we could online, we could take only 3 or 4, but there are 4 to 5 competitions, and the students are so busy that I have observed that in the national workshop, national conference or international conference for valedictory session, very few teacher members are there. But in the student workshop, we have conducted in these 35 years so many workshops. Only for students. We have never conducted any workshop for teacher. So what I observed is the students are busy till 6 p.m. in the evening, although the workshop is from 10 to 5, collecting the data, then preparing the project file, etc. So they are very busy. So because of involvement, they may not be able to give feedback properly. That may be there. But anyway, we should be aware about how many have given not, how many have not responded, and how many have total number of respondents. That one should claim first. That is what the objective. The diagrams are not right or wrong. What I have told you, that you have to choose a perfect diagram representing your situation. Okay.
Okay.
Harshini, you got it? Or
Yes, ma'am.
any other version of your question is unanswered? Yeah,
No, ma'am. Yeah, I got the answer, ma'am.
okay, thank you. Any more question?
I guess no more questions, ma'am. Thank you so much. That was so generous of you to answer to all our questions. Now I welcome our HOD, Dr. Annapurni ma'am, to share her thoughts about this webinar.
Yes. Hey, எங்கே போகுது? Yes. Yes. First of all, I thank God for this wonderful day. And ma'am, happy that we are connecting at least after COVID through these different platforms. Only because of that, we could able to have this wonderful session with a short notice. And ma'am, it is really a magical talk with a lot of interesting real life experiments. And it is an eye-opening session to the staff and students, how to connect statistics with real life situation. Hope all our students are motivated and take up some project in future. And we are very happy to have you even in future and connect with you, ma'am. It's really wonderful to have connect with you. Thank you, ma'am.
So, well, we have to say that session was so interactive and interesting. Like we lost a track of time. I guess it's time to official vote of thanks by my friend Satvika Varsha.
1 minute. I wish to thank all of you for your patience and for your questions. And I wish to thank all your teachers for saying so many things about me. And really, I'm thankful to all of you. Okay.
Thank you, ma'am.
Good afternoon to one and all present here. So I take immense pleasure to propose the vote of thanks for this webinar. I would like to extend my sincere thanks to Dr. Jyoti Shivalkar, Head and Associate Professor, Department of Statistics, Hislop College. Thank you very much, ma'am, for making us understand statistics in an experiential way by explaining us about the importance of experiential learning and letting us know about classroom experimentation and field experimentation. Thank you for making us realize that learning statistics can be enjoyable with classroom activities. And your talk was indeed inspiring and informative. We got a lot of takeaways from today's webinar. Thanks a lot, ma'am. I would like to express my heartfelt gratitude to our principal, Dr. R. Geeta, ma'am, head of the department, Dr. D. Annapurni, ma'am, and all the faculty members of Department of Statistics for organizing this webinar for our welfare. Last but not the least, I must thank G. Subhadra for preparing the invitation for this webinar and coordinating the question and answer session, and Kavya for comparing, Harshini Natraj for introducing the guest speaker, and I thank my fellow students for participating and making this webinar interactive. Thank you, one and all.
I'd like to just informally at least thank on behalf of the Department of Statistics here at SDAB Vaishnav College, on behalf of the management, principal, and everyone from the department, staff and students. It gives me immense pleasure to thank Dr. Jyoti Shivalkar for we've been chatting for a long time. We wanted to conduct this sometime in December, then a lot of things got pushed and due to exams and all that. So thank you so much, Professor Shivalkar, for such a wonderful talk. I think I have not done my teaching right. That's what I could take away. That was my takeaway. I told the students that I need to look at doing things totally differently the way the way you have been doing. So you are an inspiration, and I'm sure this is not the last workshop. We are going to pester you for more. So thank you so much. And so you should come down to Chennai now and be with our students. We'll arrange something. We'll connect and arrange something like that. Yeah.
Okay,
Thank you so much.
Thank you. Thank you so much.
Thank you, Dr. Jyoti. Though I have not been following all of your talk because there were faculty who came in and this one, but I could get it is available in YouTube, right? So we would like to circulate it to students and the more number of students. It's not only statistics students, right? I can even put forth to other disciplines also to understand how exactly this data is being collected, how simple experiments will help us to collect data and everything. So I really, once again, I need to thank you. And as Vijayashree said, so we would love to host you in our college campus also. We have a good hostel also available here. So we can put you there. And so once you come to Chennai, just give us a note so that we'll be able to have you with us. And the book which you had, the book which you had mentioned, I think, Dr. Vijayashree, you can just make a note of it, and we will try to get copies of the books for our library also.
Definitely.
Yeah, definitely. I'll do that.
Yes.
Yeah.
Thank you, madam. Thank you so much.
Thank you so much, ma'am. So bye-bye and
Bye-bye.
connect again. Yeah. Bye, ma'am. Thank you.